Yeah, at least I recorded the last one, and I am recording this one as well. So you guys can hear me, right?
Yes.
So let's wait for and leave.
No, we were the only three.
Had she left before?
We were the only three.
Oh, okay, sure. So let's just continue. I guess. Yeah, I'll start sharing again. Yeah, you can see screen and so on, right? Yeah, so I think doing this thing should work. But yeah, in general, I think it's fine. Like you can try it on your own as well. But yeah, what you were doing it's a great idea. I think I didn't know that pharmacy would have its own, like, I mean, it makes sense because in some other things for system, so things like for STDIO and so on, those things were automatically included. But the fact that you would have to do that manually is something that I didn't think that would be necessary. But yeah, I think in general, that's a good idea. Maybe you can also do this for any other files that you think are necessary here. So let's see. Yeah, memory.h as well, maybe if there is a memory.h inside that folder, right? So maybe you can do that as well. As far as I'm aware, it should sort of happen automatically with pharmacy, but if not, then just do that as well.
No, I think other than printf and scanf, everything else you need to do manually.
I see.
When you point at a function call that does it, EVA will actually show a message that you need to add this to source files to make it work.
Ah, okay, I see. That is nice. Sure, then do that. And yeah, you don't need to worry about the Win32 versions anyway. We are verifying, even if you are on a Windows machine, we'll just verify the non-Win32 version, which should be fine, I think. But yeah, then time-h and memory.h you should also add it in. So, okay, so this is done. The next thing then is basically, I'm just going to document it over here. Add EVA's version. So this should be in your this should be
no, the Win32 ones if def, not if and def.
What?
The Win32 ones are negated, not sorry, or positive. So they have to be included. All right, negative. Sorry.
No.
So this is for Unix, no?
Yeah. Okay. Yeah. You're right. Yeah. So these also need to be included. Yeah. I mean, as long as they're there. If they're not there, then what can you do? So this version should be in your OPAM install it. So in your open switch, I think it's called. Which is usually in the home folder. So for example, in my case, it was something like .opam, and then I think whatever version you have. So open switch, then there is shared pharmacy. Yeah, so it's usually in this sort of a folder, share pharmacy, libc, and so on. So you might have to do some search, look around for this folder. But yeah, it's usually in some like home opam version, share, and so on, right? Okay. So add EVA's version. This should be in this sort of a location of all the system libraries, like system headers, things like time.h, memory.h, Unix standard.h, etc. So let's just make conference of this. And fcntl.h. right? Now, when you call EVA, okay, so even before this, so just call EVA with this was CPP extra options, right? Abstracts. And then do this thing. Okay. So basically these few steps you need to do. You need to stub out time.h, which I've already done. Then you need to call EVA with an extra. So you need to call EVA in a way that it actually ignores all of the graphics code. And with this extra include folder, wherever you stubbed out time.b.h is. And finally, once you're inside EVA, you can add in these EVA's versions of these various system headers, which have some contracts which are defining how these particular system functions behave and so on. Okay. So yes, this is what you need to do to get EVA running on this, right? So this is the second part. The third part is to actually make EVA meaningfully verify, right? So the issue with this, the issue with the above, is basically that, like, when you're doing this, there are certain things that the emulator needs to work properly, which are not being loaded. So if I go to the main, right? So if you go here, you'll see that this, so in this particular line, and you can take my word for it for now, but if you stare a bit longer at the code, you'll realize that's what's happening. So in this particular line, what's happening is this, that this BIOS table lookup is being read from the BIOS binary file that had been loaded in. So the BIOS binary file was loaded in this line number 290, and it was loaded into our memory. And then the BIOS table lookup is being copied from our memory. So this is basically being copied from a particular location in the BIOS binary file, right? And if you look at the BIOS source code, you'll find that there are these sections which have these lookup tables here at the very end. So these tables over here, these are being read in this particular line, right? So the thing is that this is actually these tables are actually not in particular like need to be there inside the BIOS file, right? These can be hardcoded in your C file. So that is something that we have to do. The reason we have to do that is because if we don't do this, what will happen when you try to pass this particular file through EVA is, or CBMC for that matter, is that EVA or CBMC, neither of them will actually read your BIOS binary file, right? So without the BIOS binary file, this BIOS table lookup array will get filled with garbage values. And then the BIOS table lookup is being used in the first step of actually decoding whatever instruction binary instruction that you have. That is in the first step that happens in that this set output function there, the BIOS table lookup is being used, right? So if this BIOS table lookup has got garbage values, then this decode step will use garbage values, and your entire instruction decode process will become garbage, right? So EVA will essentially be verifying a too general version of your emulator, right? So what will happen is that EVA will assume BIOS can be anything. Hence, the lookup table can be anything. And hence the decoding can be anything. So it will try to prove things with a very general version of the emulator. right? Too general version of the emulator. Okay, so this will be an issue that might happen if you're if you just directly pass it through EVA, right? So to prevent this, what we want to do is we want to hard code in the BIOS table lookup using the values from the BIOS.asm BIOS source that we have. So this is step number 3, which is to hard code BIOS table from BIOS.asm. And this is fairly, like, you can do it fairly easily. So I think the most direct way is figure out what this address is, what this address in the memory is, right? That will correspond to a particular address in the BIOS binary, and then just use some Python script to extract the raw sort of character data from that particular binary, or use a hex editor or something like that, and then just fill up the array manually, like write in a header file that defines the array manually in that sense, right? So for example, if we wanted to do it for just one of these lookup tables, say if you go here, you have this particular lookup table here, right? So for example, you have this particular BIOS table lookup table XL80 opcode, right? So if you wanted to do that, do it for just this table, you could take this, copy that, and say define some variable over here. Where were the variables defined? Yeah, so somewhere over here you can define, say, this is the BIOS table lookup is yeah. So this is an unsigned car, so you can just say define and something like this, right? So you can define this and then use it wherever you see this particular thing. So this is something that you can do, for example, or something else which I can only describe right now. I cannot actually show you because it is a little bit more involved, but I think it will directly get your job done. Is that instead of having to change each one of these lookup tables, what you can do is you can just figure out. So go here. So this particular line number 295, this SAS line that we have here, this line is basically copying some of the data from a particular location in the BIOS binary into the BIOS lookup table. So figure out where in the BIOS binary that data is coming from, and then just write some like Python script to manually extract that data into some sequence of integers, a sequence of chars or whatever, and then just say BIOS table lookup ij is that, and just declare that in that way. So that is another thing that you can do. Okay, so this is basically what you need to do. Right, so the step would be figure out address in the BIOS binary holding the data. So extract that as, say, some comma separated sequence of ints. right? So you can maybe use something like a Python script for this if you want to automate it. Or something like a hex editor. Hex editor will probably give you like a sequence of cars or sequence of hexens, but either of those things can be made to work. And then just write a C array declare, like array definition. With this. Right? So this is something that you can do. Okay. So this step, are there any, like, I mean, I guess you'll only be able to really ask questions once you've tried this, but how, like, are you really worried about this step being somewhat too complicated, or are there anything, is there anything specific about this step that you're worried about? And, or at least what I'm describing here, does that make sense to you? Or, this little thing that I showed with the XLAT IDs, did that make sense to you?
Yeah.
Right. So yeah, so I mean, you can basically do that. So I did that only with the XLAT IDs, but there are some 20 lookup tables over here. But instead of going over each one of these 20 lookup tables and doing it manually, you can just extract the data from the binary itself and then manually encode it, like hard code it into your C program, right? And yeah, this won't be too complicated. It shouldn't be too complicated. Okay, do you think it's too complicated? Or do you think that it will be too time consuming?
I personally think, I mean, 20 tables is not that much.
Yeah, no, I
So-
mean, I'm not even saying think about 20 tables or so much, because if you look at this loop, it's just some section of data in the BIOS binary, right? So what I'm saying is, take this loop, or you don't even need to do say something like a Python script, right? Just modify the emulator, comment out everything in the main function from here on downwards, and just print out the BIOS table lookup. Run it once with the default BIOS and just print out the BIOS table lookup, right? Once you have printed out the BIOS table lookup, you can then just copy paste that into a C declaration of a BIOS table lookup, just directly. You don't even need to do it individually for the 20 tables, right? Because if you print out the BIOS table lookup, say using this sort of a loop structure, then
Okay, that was genius.
yeah,
That was genius. That was genius.
okay, sure. But like, I mean, it's yeah, you just need to somehow just get this thing right, this data. I don't know.
Yes, now it's like one step. Like
yeah,
we can even use printf to format it, and
yeah, you can use printf to format it and just format it directly, like a C array declaration. Even that's also done there. Sorry, I'll just one second. Give me one. Yeah, sorry. Yeah, so you can directly do that. Just so for example, you can do something like this. Okay, I mean, yeah, I'm not gonna write the code over here right now, but you get the idea, right? Can you hear me?
yes,
Yeah,
yes.
yeah,
It was
yeah.
genius. The Python stuff was complicated. This
Right,
is
right.
genius.
Yeah, sure. Yeah, I can see why that would be. Yeah. Yeah, I mean, I guess, yeah, sure. So you can just take the BIOS table lookup, print it out, and then you're done. So this is all assuming that I think the BIOS table lookup is the only thing that this thing is reading from the BIOS that is necessary for the decode process. All of the other things are, I think, hard coded into the code. In previous versions, so I worked on this like 2020 for doing some random thing with this as a freelance sort of a project, but there was some older version that people were dealing with, and there was 2 biostable lookups and so on. But right now, I think this is the only thing that you need to worry about. Okay, so the important thing is that once you've done this, run the code and make sure that it's working, right? Of course, remove this line so that you're not actually loading the biostable lookup from the BIOS. So comment out 293 to 295, or most importantly, just comment out the initialization in the main, which is 293 to 295 right now, but I mean, this will change. And make sure emulator is working. The way I suggest of doing this is, I mean, of course, we're not going to be able to formally make sure that the emulator is working, because of course we are only going to verify the version where the biostable modification has been done. But the way you could make sure that it's working is by running the runme script, right? So when I say run it, get the prompt, start up Alicat, make sure that you can play Alicat and so on. And do this if you have installed SDL successfully on your system, try to do this with graphics, right? So this will basically make sure that most of the instructions at least are going to get used once, and they're being decoded correctly and so on, right? Or you can also try running other things that I've given you. So you can try running the Windows 3.0 thing that I gave you. Right? So if all of those things are working as they should, then you know that this change didn't kill the emulator. Okay, so just do that. Right. So is this up to this? Everything is okay? How much time do I have? I don't have any time left, right? Are you guys still there?
Yeah,
Sure.
it's fine.
Yeah, so I think this is okay for now. We'll keep talking about more of these things, but yeah, so just do this, make sure that it's working. After that point, you should be able to run it through EVA. Like after this, you should be able to properly run it through EVA. Then you can properly run EVA and also take the errors from EVA, run CBMC. So you can do these two things properly once you made this change, right? So that's all. Okay. So yeah, so do you want me to stop right now, or do you want me to go on? Because I mean, I guess
Let's do this first.
Yeah, sure. So you guys try this, then yeah. Then the rest of the changes is basically things like figuring out unroll limits and the sort of invariant transformation that you did in your assignment, right? I mean, you didn't do it on an actual, like you didn't. No, you did run CBMC on it, right? In the assignment, once you've done the invariant transformation, like
Sorry,
Which one?
so I'm talking about taking the loop body, extracting it out, and just adding asserts beginning in the
yes.
Yeah. So the rest of it is just that basically, right? So that I think in any case we can just go over later on, or you can figure it out. I think fairly easily as well. Okay, so beyond this, there is no like 8086, like there's no modification specific to this code that you'll need to understand. Rest of it is just, extracting out this thing, this entire huge loop body, and checking whatever invariants. We'll supply the invariants are holding and so on. We'll not supply complete invariants. We'll just supply some part, like some part of an invariant that should hold. So check that is holding on the loop body and so on. Right. Similarly, when you do this, take an error in EVA and then pass it through CBMC, you'll have to somehow figure it out, unwind depths. So this is something that some other little bit of detail that you'll have to do. So yes, this I think I guess we'll talk about later on, but make this change, hard code the BIOS in, and then we can see. So yeah, maybe I'll just write this. That's easier way of doing this. Yeah. Okay, so I'll end the meeting. I'll write this up and send it to you guys. Okay. So are there any questions? Is it okay if I stop sharing?
Yeah.
So I'll stop the share. Yeah. So no questions?
Yeah, no questions.
Okay, sure. So yeah, I'll write this and send it to you.
Thank you.
Thank you.
Yeah, bye.